Record this. Okay. So this week it talked about polymorphism, which can be a confusing concept. And hopefully my video made it a little more clear. Again, I don't have my iPad with me. I just forgot to bring it. And I don't have a normal computer with my normal examples and my normal video quality. So all that's a little slack this week. I'm going back home this weekend, so things should return to normal soon. But polymorphisms, it's one of the key issues when we talk about object-oriented design. And object-oriented design or object-oriented programming, or OOP, is just the idea that we're going to use classes to organize data. And you don't have to do that. I mean, there was a long time in the world of programming where no one did classes. It was a relatively new thing in the 80s, but people have been programming in the 50s and 60s, and especially in the 60s and 70s, without the use of objects. So it's kind of a new thing. But one of the main keys of that is this idea of polymorphism. And then again, in a nutshell, it utilizes the is-of relationship. So if you have a method or something that takes an instance of the superclass, like in the example I did, if you have a vehicle, something takes a vehicle. Well, a vehicle had a name and a make and a model, whatever it had. Then anything that inherits from that superclass, so the car or the boat that we did, they all have all the member data and all the functionality of the superclass, which means that you can substitute. So if you have, think of the one we did where we had employees, and then we had salaried and we had hourly employees, and then we broke that down further into commission and all that. All of them are employees. So if you have a method that takes employees, you could also, that same method could take a salaried employee or a commissioned employee or an hourly employee, any of those things, because they all add information, they don't subtract from it, okay? But it doesn't work the other way. You can't typically, if you have a method that requires an hourly employee, then you can't send just a regular employee instance to it because it's missing data that you may need, okay? And that gets us to the idea, or kind of leads into the idea of an abstract class, okay? So an abstract class is where you have a class that's there for organizational purposes, but you never actually use it. So if we had, the other example they did in the book was a university community, where it divides up into faculty, staff, students, then it divides up into full-time faculty, whatever, all those categories, okay? You never have someone who's just an employee, right? Everybody is one other of those categories, okay? So you could make the employee class abstract, which means nobody could be an employee. But you could have an hourly employee. That hourly employee would inherit from the employee class, okay? And then the same thing with a salaried employee, inherits from that, adds to it, but you couldn't be just an employee. You had to pick one or the other, okay? So that's where the idea of the abstract class comes from. That's a pretty important concept as well. The only other, the concept, and then I'm gonna take your questions, the only other concept the book talked about was an interface. So an interface, other languages such as C++ allow you to inherit from multiple parents, okay? So you could have something that has very many parents that lead to a subclass. The problem with that is it becomes difficult if two of the parents have the same exact method, then you have to decide which one gets priority. And it can lead to some confusion. So Java has gotten rid of multiple inheritance is the term we would use, okay? So with Java, you have only one parent at most. Well, everything is from the Java.object. So everything's a Java object, but we don't have to say that. Everything has at least one parent. Sorry, it could have at most one parent, okay? So there's only one parent that you can have. It could have a grandparent and a great-great-grandparent. There's only one direct parent, okay? So if we want to have functionality from more than one parent class, our only option in Java is to use an interface, okay? And interfaces, practically speaking, get used typically when you want to unite disparate classes that don't share a lot of commonalities, but have some common purpose, okay? So the book gives the example of invoices. If there's an invoice class, that's payable. So there's some payable things that we would do. Or an employee is also payable. So they both would implement the interface of payable. Okay. If we won't get to it as my guess, but if you're doing multi-threaded programming, then you can have runnable, which is a characteristic. It's an interface that you would implement for programs that can run in multiple threads at the same time. Okay. So that's kind of the idea there. And then the book also, in the homework example, you're going to do one where you create an interface for the carbon footprint. So you're going to have many different classes. It could be a vehicle, it could be an airplane, it could be a factory, it could be a cow in a field. All of those will implement the carbon footprint, and will have to have, there'll be an obligation then to be able to create or to calculate and print out or whatever their carbon footprint. So that's where an interface, normally, a plant and a car wouldn't share anything, and they couldn't fit into our normal hierarchy of superclass, subclass. But they do have the common feature that we want to be able to calculate the carbon footprint. So that's where we use an interface. Okay. So that's kind of what this chapter is about. So I'll open it up to see if you have any questions on any of those, you want any more explanations, or if you have any questions about the homework problems in particular.
One thing that I wanted to mention is it has a limit right now of 20 files,
Yes.
but like just the first problem, I had 10, so that means it's going to have 20 uploads.
Gotcha. Yeah, and 20 is the max I can do. That's the system limit. Don't do classes for this one. That'll be fine.
Okay, so just upload the Java files.
Yeah.
Okay.
Yeah, I don't know. I'll have to send something to IT, but I have a pull down menu. It was one before until Jude reminded me, or Jude let me know, so I changed it. But my pull down menu only goes to 20. That's the most that I can do. So yeah, just don't worry about the class files for this one. Other questions?
On the interfaces.
Yes.
Problem. So that means that when we have the carbon footprint method within each of the classes, so it says each one has to have a get carbon footprint method.
Yes.
Each one will put in a different type of formula or something like that. Like we'll come up with something that makes sense.
Yeah, just make it up. Yeah.
Okay, so like, you're well, the way that I was kind of setting it up is I started with bicycle, and I don't know why, because that was probably the hardest one that I was trying to think of what to do for it. But I just put like number of gears and then like distance traveled. And so I figured distance traveled I would use in my formula or whatever. Yep. And so then I was like, for my car, I could put gas mileage and distance traveled.
Right.
And then those could be, so if those are my, if those are the things, in my constructor for my class, I could end up using those in my formula, right?
Absolutely. And all you want to do there, just make sure that you put a note in your comment how you're calculating it.
Right. Okay.
And it doesn't have to even make any sense.
Okay. So just as long as we're coming up with something that's reasonable, it doesn't matter if it, okay. Cause I was like, I started with doing research on, and I was like, this is getting too much.
That's overthinking. Yep.
Yeah.
Yep. So yeah, just something basic would be fine. The point is not calculating that for real. The point is an example where we'd use an interface.
Right.
And again, that's an example. You're taking things that would not normally be connected, and you're giving them some shared behavior. It gives you the ability to create an obligation to create that method in all of the subclasses. Okay, so that's what it's all about. Okay, what other questions do you have? I think that this chapter's homework is going to be either real straightforward or real near impossible. I don't think they're particularly tricky like some of them are, but I think you have to have a good feel for what polymorphism is and how an interface works. So that's really, they're not tricky in some way. Some of the programs we've done have been tricky. And programming in general is tricky. It's finding a way to get a computer to do something that it doesn't want to do naturally. but these seem relatively straightforward. So there's that at least.
For the shape hierarchy
Mhm.
problems, the like the second level, which has like 2-dimensional shape and 3-dimensional shape,
Yes.
those are only going to have the abstract methods in them, right?
Well, and that's a decision that you make. If you
Okay.
want to allow there to be in the world of your program a 2-dimensional shape, then it wouldn't be abstract. But you may not want that. You may want in your tree to have the only concrete classes be at the very bottom.
That's
So
how I did mine.
yeah, that's a programming decision.
Okay. I think in the or not in the problem, but in the where in the book where it was introducing like the or whatever, where it was using that shape hierarchy figure as an example, I
Right.
think it said, because I wrote it on my diagram when I wrote it, where when I drew the diagram and then I was going through the chapter, I wrote on my diagram like that shape was abstract and that 2-dimensional and 3-dimensional were abstract, and then I put like this level all concrete for the shape.
Right. Yeah,
So
that makes sense.
I think it said it that way. I don't think I made that up.
No, and looking at the problem, it only mentions 2-dimensional and 3-dimensional and nothing further than that.
Yeah, but it used the idea of that hierarchy within the chapter.
Gotcha.
Yeah.
Yeah. Yeah, that makes
Even
sense.
though that hierarchy diagram was in chapter 9.
Right. Yeah.
It was used as an example in chapter 9.
Right. What other questions do you have? And since this is Wednesday, you may not have gotten to it yet, and I apologize for that, but I had other things that I had to take care of on Thursday.
I know you spent quite some time at the beginning of this video explaining abstract.
Yes.
But when you look at a program outside of using the word abstract,
right,
it kind of looks the same as any other class. When you
Yes.
put that abstract in, does that mean if you ran a test, it just wouldn't run, or?
Yeah, it's going to give you an error. If you say,
just because of that one word,
Yes.
abstract. Okay.
if you have an abstract class called shape, for example, if you would say shape S is equal to new shape, it would say, I can't do that. I don't know what the error would be, but it would not let you create that shape.
Okay.
Okay.
Oh, seeing it says it's a compiler. Yeah. My question, when you're using inheritance, when you get to the point of using protected, is there ever like a good reason to use private if you're using protected anywhere?
It really depends on what you want to do. You use private if you want to make sure that you have control over how the member data gets changed. Okay. So if you know who is likely to be using your class, and if you trust all of those processors not to do something crazy, then you can make it protected and life's much easier for you. But if you don't know if you're writing a library for a company that who knows what department's going to use it, then if there's member data that has to fall within certain criteria, you're better off at that point making it private and then making a set where you have control. Because again, this is something that differs when you're doing programming in a class and when you do it in a job. When you do it in a job, you're not doing the whole thing. You're doing bits and pieces. You're doing parts of a bigger one. Okay. So when we're doing the program now, protected's fine because we're doing it all. We have control everywhere. Okay. But again, if I'm going to create a class and put it out into the world, then I can't guarantee that everybody else is going to follow the rules. Okay. If the rules are important, if I know that my member data, say it's an interest rate, and interest rates, people always want to put in 5.0 for 5%. We know that's not correct. It should be 0.05. If you're really concerned that somebody's going to mess that up, then you would make that interest rate not protected, but private. And then you could write the one set interest rate method that would enforce that it has to be less than 1. So that's where that comes in. It depends on how much control you want of your data. Private is the safest. Protected is the most practical as far as the ease of use. Okay, does that make sense?
Yeah.
And that privacy versus ease of use is the battle that you will fight forever in programming. Okay, you can't have both. You have to pick where you're going to come. You want enough security, but not too much, because too much makes your program crazy. If we were doing ultimate security, every password would be 100 characters. Nobody wants that. But it'd be a lot more secure. What other questions do we have?
So just to reiterate for the question about the carbon footprint, we just make up a formula for
Yes.
each of the, okay.
Yep. That's it. Okay. I'll give you another couple of minutes to have any questions here. If not, then we'll do a little, I'll talk about the project a little bit, and then I can do a little preview of chapter 11. Okay. And then we'll see if anyone has any more questions while we do that. I'll go ahead and give you another minute.
One question that I have, I found out that you have to do this, but I'm not sure that I understand why. So for the one that was the hierarchy, so it had like the 3 levels of the classes.
Right.
On all those concrete classes, I realized that on one of them, or maybe 2 of them, or like when I first started, I did the first one like the example, and then like a couple of them I forgot to add in the 2-string part.
Right.
And then later, and then it wouldn't run correctly, and I had to figure out, what was going on, and then I figured out that I had to add that. I'm not sure if I understand like why that has to have that. Is it because, to draw from the method from the higher class, it needs to have that?
Well, I don't have that problem in front of me. There's two ways to go there. You don't always have to do the 2-string class. So it's not an obligation coming from the java.language object.
Mm-hmm.
But it must be that the top hierarchy must have had that as an abstract class. So when you have an abstract method and an abstract class, that creates an obligation that you have to implement, even if you don't use it.
Okay.
So I'm guessing that's
I don't think I had that. Well, maybe it was because I had it in my test program.
If you use it, you would need it. Yeah.
Okay. I think maybe that is what it was, because I had it in the test program.
Could be. Yeah.
And so it wasn't printing all the information correctly or something like that.
Gotcha. Now, what happened to me, when I didn't do that, it didn't have all the data from the subclasses. It didn't give me an error, but you have to customize it.
Okay, yes.
Do more data. So yeah, that wasn't, I know what you're talking about now. Yeah, it's not an obligation then. It's just that that in order for it to give more information about the more specialized subclasses, you have to also rewrite the 2-string class so it gets its own version of it.
Okay, I understand that now.
Yeah.
And then for that part where I had it in the test class, I had in my 2-string for it to give. So for those shapes, you had to put in whatever was the thing that helped you get the area, and then you had to do a get area.
Yes.
So like circle, it was a radius, and then
Right.
And then it had a get area. So when I did my individual ones on my 2-string, I had it go ahead and tell the radius and the area.
Right.
And then when I did it like the polymorphically with the array,
Right.
I had it said to also give the area if it was 2-dimensional. So that was like, practicing using the if statement to draw from the higher class.
Right.
And then, or, if it was in the higher class. And then, so for all the 2-dimensional, it had to tell area. And all the 3-dimensional, it had to tell area, surface area, and volume. And so when I would print the polymorphic, that part, it was basically doing everything twice because it was doing the individual one, which
Right.
gave like the radius and the area. And then because
Right.
it was in the 2-dimensional, it was also giving the area again.
Well, that's weird.
Is that okay? Because it
Yeah, I
was,
mean, I wouldn't worry about it.
okay.
I'll try to look at the code to see why it's doing that. But yeah.
Well, I think it was because it was pulling that 2-string and then also pulling the area because I said, if it's a member of the 2-dimensional shape,
Right.
give the area. And so for all those, it did.
Oh, gotcha. That makes sense.
In addition to and I was wondering, like, should I have not put, the area when it gave them individually, the individual information? Or
Yeah, I'm not sure that it matters, but if it looked weird at all, then you can change it. But I wouldn't worry about it.
well, it just has everything, for each shape it repeats, it has area and then it repeats area.
No, I think that's fine
Okay.
because it's a test program.
So it's okay
No.
that it was just
Yes.
okay.
Yep. Yeah, I think that's fine. Okay. Other questions?
Not specifically on these problems, but how many more chapters do you think we'll cover?
I don't know. Let me check the schedule here.
Are we on week 9?
I don't know. I've got. Let's find the schedule. Who knows what week we're on? Someone knows. The syllabus should say.
I went back. At first, you were doing each week by week, and then it was topic. So it looks
Oh, yeah.
like we're on week
Yeah.
9.
Yeah,
Okay.
so topic 9, so yeah.
Yeah, it says topic 9 in Moodle.
Gotcha. So we still have a 10 and 11 week. And then that exam will be the next week.
Well, I know you had mentioned the exam, either one 3-hour block or 3 1-hour blocks.
Yes.
Will we also be given that week to review like you did the midterm, or?
Well, let's see where this puts us. So this is week 9, right? And we're doing chapter 10, which means next week we'll do chapter 11 in week 10. And then week 11, we'll do chapter 12. Let's see where this gets us. Don't like chapter 12. I don't like anything. I hate it all. So
I share your sentiments. No, it's just hard. I don't really hate it.
okay, 14 is a chapter we probably need to cover. We don't need to cover 12 or 13. 12 or 13 are GUI programming, and that's just beyond the scope of what we're trying to get through. Okay, so week 10 then will cover chapter 11 on exception handling. So that'll be next week, okay? And then week 11, we'll skip 12, we'll skip 13, and we'll go, I mean, they're good stuff if you're interested, but I don't really want to get into that. So then we'll do chapter 14 on week 11. And then that very last week of class, assuming my dates are correct. Let's see, what's chapter 15? I don't like 15 either. So we'll just say that last week will just be reviewing for the exam.
And the project?
And the project, yes, you'll have that to work on as well. Okay. So yeah, and I will rewrite that we'll do next week's chapter 11. The next week will be chapter 14. And then that will be it. Then we'll have the review and getting the project together. Okay. So just 2 more chapters and we're done. How exciting is that?
Did you decide if, I know you mentioned we were videoing that lesson as if we were presenting it and maybe working with a partner, or?
Yeah, I think that the general consensus was that it made more sense just to do it as if you were presenting it to other teachers on how to do it. I think that's what people decided.
And we're doing it on our own,
Yes.
not with, okay.
No, just
Okay.
individually. Yes.
Okay.
The partnering would be as if you wanted to teach it to the other person, but apparently it seemed like the consensus thought that it made more sense just to do it as if you were explaining to another teacher how to do that lesson. Okay.
Okay.
What I will probably do this week is put out a forum with ideas for your project. So just you can go ahead and post those just so I can everybody can see what everybody's doing. I think that'll be useful. And I'll let you know if there's anything really messed up with that. And then I'll probably next week put up the actual assignment on the project with the full specifications, what you need to do. And you can start working on your videos and all that. Okay. And those will be due at the end of that last week.
I know some other people in here did too, but I did the Tech Splash on Monday, and the went for the pre-recorded like professional development that they had. Those were like a 15-minute. Is that about what you're thinking?
That sounds about right.
We would
Yep.
be doing? Okay.
Yep. And again, I would just pop up Zoom and just use Zoom to record yourself, basically. If you want to use something else, doesn't matter to me, but you want to get it into MP4 format would be the only thing. Okay. You don't have to edit it particularly. I mean, if there are bobbles along the way, not the end of the world. If you're going to submit it to the whatever that you're supposed to submit stuff to for your portfolio, then you do probably want to get download some basic editing or just do as many takes as it takes to get it right without any bobbles. But for me, I'm not going to be that picky about it. Okay. And there will be a lesson plan that you submit and then a video explaining how it works. It's a basic idea. Okay. And again, I think I said in the other video. Yeah, what's that?
Is there information about this somewhere on Moodle? Because I have no idea what you're talking about right now.
Not yet. I talked about it, I think, last office hours.
Okay, yeah, Tuesdays don't work for me, so I wasn't here.
Yep. Yep, I think that's when we talked about it. But yeah, it's part of the grade is a project. And for the project, we're going to be doing something like you would do for a portfolio entry into, you've got to do a portfolio for these series of classes. So it's going to be teaching something that we've covered in class to a class. And we had the discussion before, if you're teaching elementary school, they're probably not going to be doing Java. So in that case, you can pick something like Scratch or something else that should work, where you're going to teach them a concept. So the concept comes from what we're doing. If you're a high school teacher, then you definitely should be using Java, I would imagine, unless you've got a good argument why you shouldn't. If you're middle school, then I don't know. I've taught programming to middle school kids before. It can be done. So I'm going to kind of leave that to you to decide which way you want to go with it, whether you'll teach them something simple programming or whether you prefer something like Scratch. If you're not familiar with Scratch, Scratch is a kind of a drag and drop programming system. It's at scratch.org, I think is where you go to get a free account.
Kind of like the Lego programming.
Yeah, it kind of is very much. Yep.
Yeah. Block based.
Yep. So, so middle school, you can go either way. Elementary school, I would definitely go with something like Scratch or even something like manipulatables. Do like blocks. I mean, like you could do sorting with like playing cards, teach a sorting algorithm, something like that, where you're doing it visually with things that they can touch. That's all okay. I'm going to leave that to your creativity to work on. Okay. And again, if you think that you should do something else besides Java, we can talk about it. And that's a possibility, but that's the basic idea. Yeah. You're just going to be doing a video where you demonstrate, you're going to write up the lesson plan. You're going to do a video where you demonstrate that you could give it to other teachers as a way something they could do, an activity they could do in class.
Okay.
And you guys know the format of that far more than I do. Whenever I look at lesson plans, I'm like, I'm so glad I don't have to do these because they don't make any sense to me. So to me, a lesson plan is a series of bulleted lists that I make as notes to myself, what I'm going to cover in class. So that's all I do. But anyway, I understand. I'm not denigrating the value of lesson plans. I've just never been taught how to do
So
them.
that's how everybody does them for themselves,
Yeah.
is just, they come up with their own system and make their own
Yep.
notes and stuff like that.
Yep.
It's when you have to, the only time that anyone follows a template, I feel like, is when you have to turn it in for something.
Gotcha. Makes sense. That
Like
makes
if your
perfect sense.
principal wants a certain template, or if, or whatever it might be.
That makes sense.
Yeah.
Because it does seem awfully cumbersome for day to day, unless you had a real good reason to do that. So.
That
No,
lesson-
mine look like a weekly page, and then like in the box I have like what we're doing.
You must
So-
have an easygoing principal. Ours are like,
If it was
5
if it was
pages
office
long.
space, we would call them TPS reports. For those familiar with that movie,
With the what?
I said if it was Office Space, we would call them TPS reports.
There you go. Yes.
Yeah. Paperwork for the sake of paperwork.
Mhm.
Gotta have something to do. But bureaucracy creates jobs. Think of all the people in your school district who do nothing but move stupid pieces of paper around. Do you want those people to not have jobs and be on the streets? No. So we're supporting our neighbors by giving them something useless to do that makes us crazy. At least I tell myself that when I'm doing paperwork to avoid the rage that would come otherwise. But yeah. So if there are competing standards for lesson plans, do whatever you normally do. Assume that you're giving it to your principal and give me that. That seems reasonable.
Well, it would make sense to like for us to go ahead and use the template that they have on like the Virginia Open Ed
Oh,
resources.
yeah, they have their own template. Good. I'm glad you know.
Yeah,
that.
they have like places for you to put in the objective and which
Gotcha.
standards and all that.
Well, and for this assignment, that makes sense. You're not really doing it, so you can't leave anything out. You're sharing it with other people, so there's a lot more.
Yeah,
For
because
me-
you need to tell them like which level it is, what standards being covered, and all that.
For me, and I assume for you when you're teaching too, you know what students, you know the whole semester where you're headed, you know the schedule, so you can have a much more abbreviated notes because you have all the background. So this has to include all that background stuff. So it makes some sense. Okay, so the form will go up today or tomorrow, just to throw some ideas out there about what you're thinking about. You can get feedback from the other teachers in this class probably have better feedback than I do in some ways, but I may or may not have questions about what you're doing and ask for some clarification. And then next week, the actual assignment will go up on Moodle. It won't be due until the last week of class, but I'll have the formal specifications. If those look wonky and they don't make any sense, someone let me know. Okay, again, when it comes to the teaching part that you guys do, that's not my world. I've never been in that world. So I may say do something that's really dumb or really not standard. I'm trying to make it something that's standard and makes perfect sense. If it doesn't, let me know. Okay.
Are
But
you on the Open Ed website at all?
I'm not. I probably should be.
Because then you could see what it looks like when someone
Yeah.
puts in a resource.
Yeah, I'll look that up. That makes sense.
I bet Heather could give you like the information about joining that group even, and then you could see what we've done so far.
That makes sense. Yep, I will do that. I will send her a message. That's a very good idea. Thank you for that. Okay, any questions about that? Or has anyone else had any other questions about the chapter? Okay. So really what we're saying then is that we have got most of what we're going to learn in Java programming. Okay, we've got most of the stuff that we're going to take care of. And I think we're not in a bad spot. We've learned all the basics for sure. Okay. What we have yet to learn, what we're going to learn in chapter 11 is just more of the error handling. Okay. We've been a little loosey-goosey with making sure that our users are inputting what we ask, which when you're a new programmer, you have to do. But if you're going to make any kind of program that you're even going to give to your colleagues, then you need more error checking. You need to make sure that if you ask for a date, that they type a date, and if you ask for numbers, they give you numbers, the right kind of numbers and all that stuff. So chapter 11 talks about that idea of the error handling system a little bit more, okay? The exceptions, we call it in programming. And then the last chapter we're going to cover on chapter 14 is going to be on strings, characters, and regular expressions, okay? So we've been using strings, but strings are kind of their own world of functionality. The string class in Java has a lot of different methods. There's a lot of things you can do with strings. And being able to effectively manipulate strings will separate you from having to write a really long, difficult program and a very efficient program. Okay, so that's one thing we'll talk about. And then the idea of regular expressions. Regular expressions are very powerful shorthand characters that we can use to do searches. Okay, so we'll talk a little bit about that. We won't get in super deep, but just to, to have an idea. Sorry, my allergies are killing me. The Ohio River is not good for people with allergies, okay? And then the book has a lot more in it that we're not going to get to, okay? So a lot of that, the chapters 12 and 13 we're skipping, do things with doing applets, doing Java graphical programs. So that's certainly a whole world that you can get into. If you were going to write programs to use, you probably would want them to be graphical. That's where the world is today. So you can certainly look more into that, okay? Then there's a lot of other topics in here that you can get to in creating files is one we won't get to. Let's see, we got recursive programs in chapter 18, which again, we're not going to get into. Searching, sorting, linked lists, stacks. So the second half of this book are basically going to be the things that you're going to talk about with Dr. Carter in data structures, okay? So how to implement them in Java. So if you keep the book and have it with you, then when you get to data structures, I think she's doing data structures in Python as my guess, but you'll have this book as well to do other examples in Java, okay? So that's why the book is so huge and why we're only covering like half of it, okay? So, I mean, that's kind of it. And one thing I don't think I've mentioned, maybe I did early on, Java is not JavaScript. So if you ever see JavaScript, think, oh, that's the same thing. Not at all the same thing. It's a separate language. JavaScript is big these days, which is unfortunate. Most computer scientists really are not fans of JavaScript, especially people that teach programming. It was designed quick and dirty, and it shows. It's a very awkward language, I think. But it was made to work, it first worked inside of web pages. So web pages are huge, of course, they're everywhere. So there's a lot of jobs in JavaScript programming, but it is a totally different world. You know, and it's not really easier. It's lighter weight in some ways, but you know, I think you would, I'm guessing you would agree. If you were going to teach your students to program, you would probably start them off in Python. It's without a doubt the most straightforward programming language. Okay. But you had to get to, so Java is probably a good choice for the second language. You know, which I think makes some sense. But yeah, JavaScript, don't mess with it unless you want to do a web stuff. But it is important, I think, that you know that it's not Java. There is a difference. That's the main takeaway there. Okay. Yeah. What else do you want to know?
It's funny when you said that about learning to manipulate the strings coming up, because I didn't realize until partway through the exam when I was trying to make some of the data be strings.
Yep.
And I realized that we had not done that.
Yes.
And then I had to change it all.
Yep.
Because I was like, oh, I don't know how to make it do what I want with this.
Yep.
And then I had to change it all.
It's so weird that they introduce strings in every textbook in whatever language. They introduce it like it's just a variable type, right? Like you could have an int or a float or a string, but they're not. They're their own class with all the stuff, but they always put it along later. But yeah, they're very powerful in most languages. So yep, you'll learn all kinds of stuff that you wish you would have known way back in chapter 2, probably.
I think all these textbooks that we've used have done that. Even in a discrete math, it seemed like the next chapter you were like, oh, if I'd known that then.
But you
I don't know if
know,
it's part of the problem solving or.
yeah, it's part, but it's also something like a programming language is shallow but wide, right? There's so many things you can do. There's not a normal progression. You know, you have a base set. To write a program, you have to be able to do, you know, basic statements and assignments and some loops and some selection structures. But beyond that, you could go in any direction, you know, and you just have to pick. So yeah, it's hard. There's no good way. Some
Yeah.
things, if you're teaching American history, then you start with the Pilgrims and then you go up, you know, and there's structure to that. You don't talk about World War II before World War One, but in programming, once the basics are there, it's a whole world that any order could make sense. It just depends on what you're trying to do. So yeah, it's always complicated.
As far as that, like the order in the textbooks and that kind of thing goes, when I started on chapter 10, I was very surprised that it directly had like the answer to the problem that we did for chapter 9. I was like,
Yep.
well, that would have been nice to
You
see.
could have worked there. Yeah, that's funny. It was funny. You're right. I saw that too. And I'm like, okay. Again, this is not my favorite textbook in the world, but it's a well-used textbook. It's used a lot. So, and if you have students that get way into Java, there's a lot there. I mean, they can learn a lot. You can just keep this in your classroom and say, go look at that. Don't bug me about it. And they'll learn a lot of stuff. And Java is one of the big programming languages. Java, Python, C++. Those are the biggies right now. Anything else you need to talk about? Okay, so why don't we go ahead and close it up for this week? We were a little long last week, so last time, so we're a little short this time. And yep, if you do have questions, I am going to be around. I'm still in Kentucky, like I said, for the rest of the week, but I do have email and you can text me and all that stuff. I can still do videos if I need to do an example of anything, and that would be fine. Okay. And if not, we'll probably go back to Tuesday, Thursday meeting time again next week. Okay, unless something weird happens, but that should be the plan. Okay. Okay, you guys have a good rest of your week and enjoy the precious days before school starts again. That seems to be rearing right above us. We'll soon hear, we always call them everybody in my family is an academic, so we always talk about the back to school bugs. You know, when the bugs start revving up toward the end of July, you're like, okay, that means school's coming soon. So, but we've never stopped, have we? We've worked all summer long because we're that dedicated to the advancement of knowledge. But anyway. Okay, so I will see you guys next week then.